Hey everyone, welcome to this particular talk, and super excited to have you all here. This is actually my very first time talking at any in-person conference. I mean, I'll not say that I'm not nervous. I am, but after having like pretty nice conversations throughout the day with my friends and with everyone, I think I'm pretty excited. And part of the reason is because of this particular talk. So today we are going to talk about open standards and how they are empowering cloud native education, cloud native innovation, I'm sorry. So before I get on to the main crux of this particular one, I actually wanted to know more about the audience. Has anyone here ever heard of this particular term, open standards or cloud native open standards before? Anyone? Okay, I see a few hands here. I mean, for those who haven't raised their hands right now, I'm pretty sure that while we'll talk about the concepts which are involved, you'll know that you already knew about this, but you didn't know that it existed in the umbrella, which was primarily called as cloud native open standards. You'll definitely learn about that today. A little bit about me. My name is Kunal Verma. I am working as a DevRel at Kubesimplify, where we are simplifying the cloud native and WebAssembly ecosystem for everyone. So make sure to check us out. And I'm also the maintainer for the Commiser project, which is a cloud agnostic resource manager for a multi-cloud environment. So it can help you to basically have your multi-cloud environment costs at a single place. Pretty nice tool, you can definitely check it out. And I'm also an open source and cloud native advocate. That means I really love helping people out in getting started with open source, cloud native, and with whatever experience that I have gained through the past 3 years. And yeah, I mean, it's just amazing to get involved. I'm sure you all will agree with me here. You can follow me on Twitter and LinkedIn. I am pretty much active on both the platforms, and you can definitely reach me out if you want to have a conversation about cloud native and DevOps and all that stuff. So to understand open standards, I'll keep this talk very simple. This is because this is a very beginner-friendly session, so I'll keep this very simple. Let's start with the most basic question out there. What is an open standard, right? Let's start from here. So let's break down these two terms. First, start with standard. So a standard is basically a set of universal. Yeah. Yeah, sure. Okay, so we'll be back in a couple of minutes because I mean, some of the people are still joining in, so I really want that we have a nice, diverse set of audience right now. We'll start in a couple of minutes the talk, if that's okay with everyone.
sleepwalking. Or do our dreams awaken something higher from within us? And finally show us that we are heroes. With many voices will save us. What does it mean to be a dreamer?
Okay, cool. Let's start things again then. Hey everyone, welcome to this particular talk. Thank you so much for joining me here today. And today I'm going to talk about a pretty interesting topic, which I definitely believe that a lot of beginners out there and the people who are actually in their early careers in the cloud native ecosystem should definitely be aware of, and that is open standards and how they are actually empowering the cloud native education, cloud native innovation, I'm sorry. So little bit before starting the main crux and before diving into the talk, I actually wanted to know more about the audience here again. And anyone here who has heard of this particular term before, open standards or cloud native open standards? Okay, I see a few hands from this side. But the people who hasn't raised their hand, I'm sure you would be aware of the terms that we are going to talk about, but you wouldn't, you wouldn't be aware of that they exist in this kind of umbrella, which is cloud native open standards, right? So individually, you would know these terms, and I'm pretty sure of that. A little bit about me. My name is Kunal Verma, and I am working as a DevRel at Kubesimplify, where we are actually simplifying the cloud native and WebAssembly for everyone. We create content, blogs, and all that amazing stuff, so make sure to check us out. I am also the maintainer for the Commissar project, which is a cloud-agnostic open source resource manager that can help you to track and monitor your cloud costs in a multi-cloud environment. Pretty interesting tool, and I'm not just saying because I'm the maintainer there. It's definitely a very useful one, so you can definitely check it out. And lastly, I am an open source and cloud native advocate. That means I really love helping people out in getting started in open source, DevOps, cloud native, and all that amazing stuff because it's just amazing to get involved. And I'm sure that a lot of you would agree with me on this. Lastly, you can definitely follow me on, if you like my work, you can follow me on LinkedIn and Twitter. You can also reach me out there on these platforms. I'm pretty active on both, and we can have a conversation about DevOps, cloud native, and all that stuff. Cool. So let's start. This is a beginner session, so I'm going to keep things very simple for you all. Let's start with the most basic question out there. What is an open standard? Let's start from here. So let's break this term down. Firstly, the standard part, okay? So a standard is a set of universally accepted protocols and formats for different services and tools. So here, universally means that a lot of communities join together to set these particular formats and tools so that the tools which follow these particular formats are interchangeable with each other, right? What does open mean here? Any guesses? What would open mean here? Anyone? Yeah, exactly. So means open source, right? It's accessible to all. the public-facing community can participate in the development, in maintaining these open standards, and also in the future changes that these open standards may have, right? So the open source communities, all the communities around the ecosystem have a say in all these particular processes of these standards. Now, in order to understand, right, why do we need these particular standards, right? So the question is, why do we need them? And to be honest, you've got to wait till 5:20 p.m. till the end of this particular talk to get the answer. And I hope you really stay till the end as well. Now, in order to know, right, let's start with a little bit of story. Let's go back in time and see how actually things got started in our ecosystem, the cloud native ecosystem. So it all started with Docker, right? Everything we know in the containerized ecosystem, the container revolution started with Docker, right? So if we see a little bit about Docker, it launched in 2013, right? And it quickly became the de facto container technology. Everyone was actually using Docker to use containers in their organization or in their company. Because Docker, I mean, containers existed previously as well, but with the introduction to Docker, it got numerous benefits to the ecosystem. Some of them are mentioned here. One was portability of the containers, and other was it really helped in the rapid deployment and scaling of the applications, right? And this is sort of a graph given by Datadog, and you can see the adoption, the massive adoption of Docker from where it got started and how the graph is inclined towards how the companies started using Docker and how they adopted it. So it's basically Docker was the one big thing in the container ecosystem. Okay. Cool. So the next thing that we got to know is Docker actually gave the rise of a diverse container ecosystem, right? So the story continues. This is not the end of the story. So Docker paved the way for containers, right? Everyone was talking about containers once Docker was launched, and every company wanted to use the feature of Docker and in general the containers, right? In general the containerized ecosystem. Every company and organization wanted to use it. But Docker also had some limitations, right? And it's not a bad thing, but every tool has some advantages, disadvantages. But if we also got to mention that Docker had some limitations as well. And if you look at the bright side, Rocket, which is actually another containerization tool, it was launched in 2014 by Core OS. And the main aim of launching Rocket was basically to improve on some of the limitations that Docker had. For example, Docker had some limitations related to security of the containers, right? How we can have secure containers. So Docker had some limitations in that particular area. So for that, the solution, Rocket, was launched by Core OS. The important part to note here is, and the bottom line is that the container ecosystem journey that we know right now, everything started from Docker, and then we saw a rise in the container technologies as the demand of them increased, right? So essentially, that means is everyone was talking about containers, right? Containers everywhere. So what was the need of the hour, right? At that particular time, as everyone was talking about containers and people were actually talking about different use cases of containers, we needed different tools as well, right? So the need of the hour was kind of a standard to pave the way for new technologies, right? A set of fixed protocols and formats that future container technologies can use and they can be leveraged. And then we can set that kind of a bar for the container technologies to be developed in the future. And that actually comes, and we actually come to the very first open standard in our list, which is called as Open Container Initiative. So the very first one, this is the very first open standard that we have on our list. And if you look at the basic definition, this is directly from the documentation. The Open Container Initiative is an open governance structure for the express purpose of creating open industry standards around container formats and runtime. So this was the very first open standard, and this was created in June 2015 by leading container technologies out there, Docker, Inc., Core OS, and many more. And the main aim was container globalization. How we can set these formats and protocols for the future container technologies to be developed in the future, right? So that was the main aim of OCI. Now, let us have a look at some core principles on which OCI was based upon, right? The number one was composability. So composability here means that each and every container should run independently, right? And I mean, in a way, they should be connected with each other through networks, but every container should be independent of each other's behavior. That was the number one principle. Oops, okay. The second one was decentralization. So decentralization here means that every container should basically be OS independent. So we all know that containers are OS independent, right? So every container should have the same behavior despite of the environment it's running upon. And we all know about the OS independence of the container. So that's how it came to be. The OCI is the reason that the containers are OS independent right now. The last one, the last principle which OCI was based upon was minimalism, that every container, it should be very simple to start up a container, right? The container should start like a very simple process when it came to, deploying an application there. And we have a very nice example over here. You can see we just write docker run -d nginx, and you have an nginx container running. So the main principle was every container, each and every technology should just start a simple process. It should be very simple, just a single command to start a container, right? So these were some of the core principles that OCI was actually based upon. And now if we see, let's have a look at some of the specifications of OCI. So these are the actual rules that OCI had created, and these are under the OCI umbrella basically. So these are basically divided into 3 sections. We'll discuss each of them in detail right now. So the number one is the image spec, right? And all it did was it described how a file system bundle should be packed into an image, which was officially called as the OCI image, right? So in the image specification, you will find all the information, all the basically rules that needs to be followed in order to create an OCI image, right? It basically defines how a file system bundle should be packaged. The goal was to create tools for building, transporting, and preparing an image to run. Right? So how do we prepare a container image? How would it look like? How would we structure a container image? So everything is mentioned inside the image specification, right? And these are some of the tools that are basically following the image specification. We have Docker, we have BuildKit, we also have Podman right here, and we have a bunch of other tools that have been now developed, and each and every one of them follow this particular image specification right now. The second is the runtime specification. So first we created an image, and then you can guess what is coming up. So how to run that file system bundle, which we packaged with an OCI compliant runtime, right? So container runtime, which complies with the runtime specification of the OCI. Now, this specifies the configuration, the execution environment of a container, how the container would look like when it's executed, and what would be the entire life cycle of a container at runtime. So entire specification in the runtime specification basically describes all these particular things, that what would happen how would the image that we created in the first place, the OCI image, how would it run? So the runtime specification actually defines these particular things. And this is a pretty important part because, as I mentioned previously, that the leading the container technologies, which was Docker and CoreOS. And Docker, the container runtime which Docker used is called as runc, right? So Docker actually donated runc as a reference implementation for the runtime specification. That means runc was the very first runc was basically the very first runtime specification that existed, and everything and every tool that we know right now is sort of based on the runc specification, the runtime specification. These are some of the examples of the tool from the ecosystem. We have kata containers, we have containerd, and we also have gvisor, which actually follows the runtime specifications. The next is the distribution specification. So you see, we are actually going in sort of an order, right? We created an image, we ran that particular image, and now we are talking about distribution of that image, right? And the main aim here was to standardize the API for image distribution. That means, and this was actually based on the Docker registry HTTP API version 2 protocol. That means the Docker Hub that we all know today, right? That we use in order to store our image and in order to share our particular images. These are some of the few tools from the ecosystem which follows the distribution spec. The Docker Hub, we all know, ECR, and the Google Container Registry as well. So these are the OCI specifications, and these are everything that OCI actually defined in when it was basically created. Now, OCI was created, right? We defined the protocols and set of rules that we needed to run the containers, and every organization, every container tool that was developed after this would follow these particular specifications, the image spec, the runtime spec, and the distribution spec. So then we come on to the phase 2 part, right? After container globalization. Can anyone guess what is the phase 2 here? What happened after container globalization? Anyone? Exactly. Exactly. Nice. So we come on to container orchestration, which was the next big thing, right? And I mean, we are talking about container orchestration, so how can we not talk about Kubernetes? So Kubernetes is welcomed into this particular story. And this is the exact line that the initial creators of Kubernetes, which was Brent Burns, Craig McLuckie, and Joe Beda, said that while Docker was great at building and packaging individual containers and running them on individual machines, there was a clear need for an orchestrator that could deploy and manage large number of containers across a fleet of machines. So here we are talking about, okay, it's good that you're running single containers, but what about if you're running multiple containers, and that too on multiple set of machines, right, a fleet of machines. So that is what the initial problem statement was, and that's how Kubernetes was born. So the version 1.0 was launched in 2015, and the goal again was to run multi-containerized workloads or applications across multiple machines, right, multiple fleet of machines. And when Kubernetes was launched, it quickly became the center point for companies when it came to working with containers, right? Because when we are talking about a production use case, we definitely want to run multiple containers, right? And Kubernetes was the solution for that particular problem. And slowly, Kubernetes started to gain very, very much popularity in the ecosystem, and it also got accepted into the CNCF, right? So it got accepted into as a CNCF sandbox project. And quickly, we understood that there were a lot of different functionalities to Kubernetes, right? So each and every organization out there tried to extend the functionality of Kubernetes for the diverse use cases that it had. And that is how the CNCF landscape was born. So if you see some of the stats right now after Kubernetes was involved in the cloud native ecosystem, you can see how the number of contributors this is the current stat right now from a very recent report. So you can see, I mean, we all know that Kubernetes is one of the largest projects in the open source ecosystem. So as I mentioned, Kubernetes is the reason why the cloud native landscape started, right? And all of the tools that you see in the cloud native landscape, the main purpose was to extend the functionalities of Kubernetes. And now we see that the cloud native landscape has grown to a massive number, and we often refer to it as the overwhelming cloud native landscape. And I mean, a lot of folks actually ask me that, hey Kunal, why do we have so many tools in the ecosystem? This is why. Because Kubernetes was launched, and every tool that we know in the cloud native ecosystem had basically one purpose, which was extending Kubernetes functionality. So now, Kubernetes was great, right? It is great right now, but we are talking about at that particular time, Kubernetes was great. But there were some challenges, right? Again, as we talked about Docker, Docker was great. Docker brought a revolution, but there were some challenges. Again, with Kubernetes, Kubernetes was great, but there were some challenges as well. So let's discuss about these challenges. So here you can see this is a very simple diagram of a node, basically. So you can see that we have the kubelet, and then we have the container runtime which runs on that particular node, right? And we are talking about the early days of Kubernetes. So you can imagine that at that particular time, the two very famous container technologies were Docker and Rocket, right? The container runtimes. And Kubernetes actually supported only these two. The container runtime component in Kubernetes only supported these two runtimes at that particular time. Now, the challenge here was, one of the main ones is the logic of these particular tools was deeply ingrained within the Kubernetes source code, and specifically the kubelet, right? So it brought mainly two challenges. The number one was a low rate of new feature development. Now, you see, Docker is a separate tool, right? And Rocket was a separate tool. Both were being handled by separate organizations. So they both basically had their own release cycles, own feature development, and then they had to be, the new features which were developed separately, they had to be integrated into the Kubernetes source code. And we all know how lengthy the Kubernetes release cycle is, right? So it was very difficult to basically add new features to this particular tool, and that's why low rate of new feature development, right? We saw a very low rate of the new features getting integrated into Kubernetes. The second challenge, which I definitely feel is one of the most important ones, is the developers who were actually working on these separate tools needed an in-depth knowledge of the Kubernetes source code specifically. As I mentioned in the first point, that the logic of these two tools were deeply ingrained with the Kubernetes source code. So imagine a developer working on these particular tools, right? And when it came to basically creating a new runtime. So the developer had to first go through the Kubernetes source code, especially the kubelet code, see how we can integrate it. So basically, the bottom line is the developer had to have an in-depth knowledge of the Kubernetes source code itself to create a new runtime, which was very time consuming, and I think it doesn't make even sense as well. So again, what we needed was, there was a need of a standard, right? Again, we needed set of rules and protocols that can be followed so that multiple different tools can be used with Kubernetes. And I mean, they could be solving the same problem, but we needed more and more tools to increase the functionality of Kubernetes and to make Kubernetes more extensible. So then comes the second open standard in our particular list, and which is the container runtime interface. How many of you have heard this particular name? Yeah, see, you have I see a lot of hands up. So the container runtime interface is basically the plugin which enables the kubelet to use a wide variety of container runtimes out there. And this statement is important, without having the need to recompile the entire cluster components. So the meaning is that we added a third layer besides the kubelet so that it can be integrated with multiple container runtimes which were being developed and which will be developed in the future. So the CRI plugin came out in the Kubernetes 1.5 release, and some of the internal components that it consists is the protocol buffers, gRPC API, and the libraries. I'm not going to go into the depth of this, but the bottom line is that the CRI basically defines the main protocol, which is the gRPC API that helps in the communication between the kubelet and the container runtime. Cool? And this is something that how it looks. It's open source, so you can check out this. This is actually from the Kubernetes or GitHub repository, so you can definitely check it out. And now, if you see the picture, so this is a very bird's eye view of how things change. So you saw the previous diagram where we only had Docker and Rocket. So now we have a layer of CRI plugin in between, and we can use multiple container runtimes with it, right? And these container runtimes are actually OCI compliant. So they have to be OCI compliant. So these are the OCI compliant runtimes, and you can choose any of them. I mean, these are only 4 tools, but we have a massive number of tools if you see the the CNCF landscape. So that's how everything changed when the CRI plugin was launched. Now, if you see, the CRI, the runtime is only one aspect when it comes to container. We have 2 more aspects. We have the storage aspect. How can we use storage solutions out there? And the second aspect is how can we use networking solutions out there, right, in the container ecosystem. So the community thought, why should we stop here, right? We created something that would help to integrate multiple runtimes into Kubernetes. So why should we stop here? So there were different functionalities in Kubernetes, and this basically paved the way for other open standards that exist right now. So let's discuss them one by one. The number one is the CNI. Who has heard of CNI before? Cool. Yeah, see, a lot of people have heard it. CNI is the container network interface. And this is the networking solution of your Kubernetes cluster, and that's how the containers are basically able to communicate with each other, right? This is the networking solution. And this is, again, you can compare it with the CRI plugin. So it's a layer between your container runtime component. So everything which I'm mentioning right now is a part of the container runtime component itself inside a particular node. And you can see that these are the few tools from the ecosystem which actually adheres to the CNI, which is Cilium, Flannel, and ViewNet. So you might be familiar with these solutions, these networking solutions that you can use within your Kubernetes cluster. So CNI basically defined the set of rules and protocols that you can use to create your own networking plugins, and you can directly use them with Kubernetes, right? The next comes the storage aspect, right? And this is the container storage interface. And this basically defined this again basically defined the middle layer, which helped to integrate a lot of storage solutions out there in your Kubernetes cluster. So I mean, these are the few examples from the ecosystem. We have OpenEBS, Longhorn, and we also have another example, which is Kasten by VM. Then, I mean, we have talked about the container aspect, and quickly, we also saw a rise in the service mesh side of things as well, right? How we can manage traffic, how we can manage load. So the community also thought, okay, let's create an interface, an open standard that can handle the solutions in that particular space as well. So then we have the SMI, which is the service mesh interface. And these are some of the solutions, again, from the ecosystem, Linkerd, Istio, HashiCorp console. I'm actually not going into the depth of all of these because I'm just telling you the idea behind them. You can definitely explore more, and I have also given the resources you can refer to explore more about how are these tools being developed, and these are actually are open source, so you can contribute to its development as well. The last one is the cloud provider interface. Has anyone heard of this particular one before? Okay, cool. So I've seen a few hands here. So cloud provider interface is what enables Kubernetes to be integrated with the cloud providers out there, right? It basically defines the formats and the set of rules which Kubernetes uses to be integrated with certain cloud platforms. So here are a few examples. You can use AKS, Azure Kubernetes Service. We have GKE, and we also have the EKS, which is the Elastic Kubernetes Service. And that's how you are able to use Kubernetes with numerous cloud providers which are out there. Now, these are the few main ones. So these are the open standards that are continuously evolving into the exist, and these are revolving around the ecosystem. But before I finish, I also want to talk about two new spaces that have recently come up, and I'm pretty excited to see the development in these particular ones. The number one is the observability space. Right? So the standards, basically the main aim is to simplify instrumentation, lowering the data aggregation cost, and standardizing formats and frameworks to ensure the visibility across the stack. And when we are talking about the observability stack, we mean the metrics, the events, the traces, and the logs. This is the typical observability stack, and the community thought, how can we create these sort of standards and protocols for this particular space, because we have a lot of tools right now in the, who are solving this particular observability stack. And OpenTelemetry is the one that started this entire thing, that started the revolution of open standards in the observability space. So that's how things got started, and this is actually a CNCF incubating project. You can definitely check it out. And this is how basically the observability space, the open standards in the observability space came into being. And now, if we actually have a CNCF report as well. I'll link it to the resources. You can check it out. You can see we have a lot more open standards when it comes to the observability space. The second one, which is pretty interesting, is the application deployment, right? And here the aim was basically how we can simplify the application deployment on any platform while also focusing on the developer experience. So we all know, right, when we want to deploy an application of Kubernetes, right? So we got to create two particular files. One is the deployment file where we create the pods, and one is the service file, which allows the pods to to have the inbound and outbound traffic. So how we can simplify that process, right? Because everyone wants simplicity, right? Because we have a lot of complex use cases, and we don't want to write too many files for just a simple application deployment. And here, one of the open standards which recently came up is called as Open Application Model, or OAM. And this basically defines a very new way of defining how you want to deploy your application onto Kubernetes. You can definitely check it out. It's pretty amazing. I got introduced to this during a hackathon, which was recently organized, and you should definitely check it out. It's pretty amazing. And one of the tools which is actually working in this particular space is Kubevela. Who has heard of Kubevela before? Cool, so people have heard it. So Kubevela is actually working upon this open application model, and they have defined a very easy and nice way in order for you to define how you want your application to be deployed onto a Kubernetes cluster. Pretty interesting tool. And one of the tools which is also working in this particular space is Crossplane, which defines how you can customize, how you can create your own control plane without the need to write much code, right? So this is, again, one of the tools which is working in the application deployment space. Now, when we started, I told you that you have got to wait till the last of the talk to get an answer to the question, why do we actually need them? And to understand why do we need these open standards, we got to understand what impact they brought into the cloud-native ecosystem. The very first one is innovation for the vendors, right? So when we talk about a company who's actually focusing on building tools, so previously, without these open standards, the company had to also spend much time into thinking how they can integrate it with how they can integrate this tool with Kubernetes, because as I told you, Kubernetes was at the center, right? And every tool out there wanted to increase Kubernetes' functionality. So organizations had to spend a lot of time in thinking how they can integrate it into Kubernetes and how that can be done. But with the introduction to open standards, that particular part was already done, because we had set of protocols and standards that were already set. Now the company, the vendors, could spend more time innovating their tool and solving various other use cases of a particular end user, right? So innovation was one of the major impact onto the vendors community, if I talk about that. The second one was extensibility for the end users. As I mentioned, the vendors basically focused more on innovation, right? So they created more and more tools they created more and more tools for the end users. And now the end users had a way to benchmark these tools just on the basis of the features they were providing, right? So it brought extensibility for the end users to basically benchmark these tools just on the basis of the features that every tool had. And the last one is interoperability for the community. So what does this mean is that we have multiple solutions for the same problem, right? We have multiple networking solutions for the networking aspect. We have multiple storage solutions for the storage aspect of the containers, right? And the community, whoever wanna use these solutions, can interoperate between these tools without worrying, because the base is same. The set of rules and protocols on which these tools have been built are same, right? So this is sort of the impact that this summarizes basically the impact which the open standards actually brought with itself. I hope this makes sense. Yeah, that was it from me today. I hope you at least learned one thing new from this one. And if you have any questions, you can reach me out on my Twitter and LinkedIn. And you can also scan this particular QR code where I've curated a bunch of resources for you all to get to know more about these recent developments in the open standards, and especially the observability and the application deployment space. So you can definitely check it out. And yeah, thanks for attending.